So looking at question 13, says here that Simon knows that $30 per ticket will sell 500 tickets. Okay. He also knows that for every $1 increase, 10 fewer tickets will be sold. So model the revenue as a quadratic function. Okay, so the best way to go about doing this is just to give examples. So when it's $30, when we have a price, so let's try and remember the numbers. Okay, when we have a price of $30, price, I'll have a revenue of, let's not do revenue. We'll sell tickets of what? How many tickets will we sell? It says 500 tickets. And then revenue is just based on 30 times 500. Dot means multiplied. Now, the next step is to say, for every $1 increase, 30 plus 1, I will sell how many fewer tickets? 10 fewer tickets. 500. Take away 10. And the reason I'm not solving it right away is so we can see a pattern. So what do we end up getting? We end up getting revenue is equal to 30 plus 1 times 500 minus 10. And if I increase it again, 30 plus 1 plus 1, we have to say to 500 minus 10 again. Or, in other words, we can say something like 30 plus 2 times 1, right? And 500 minus 2 times 10, right? And then next time we do it, if we increase it again, and that's equal to 32 really, if you think about it. The next time it'll be 30 plus, 3. 3 increases. So I'll increase it by $1 3 times. And this will decrease by, $10 3 times. And of course my revenue would be 500 plus 1. My revenue would be this times this, which would be, anyway, the whole point of this is to develop a pattern, right? So let R of X equal revenue, represent revenue for X price increases. Now, if you think about it, number of increases. Oh, terrible. Number of price increases. And in the first place, it's 0, then 1, then 2, then 3. So if you think about it, R of X is equal to, if that's X, and that's X, R of X is equal to 30 plus X 500 minus 10X. And that's essentially how you model revenue as it relates to price increases. So that's part A, model the revenue as a quadratic function. What ticket price will maximize revenue? Okay, so what ticket price will maximize revenue? Well, you got to recognize that I have this. This is a quadratic formula or a quadratic equation. It's going to look something like this. Let me see. It's going to look something like that. And the midpoint is going to be where a maximum is. So this is x, this is r of x, right? And the reason I know that is because I have a minus with the as a value of x squared. When I expand this, if I expanded this, I know I'm going to have a negative there as the coefficient to whatever ends up being. It's going to be minus 10x squared. Okay, so find the zeros. So that's at r. This here is at r x equals 0. So 0 equals, at rx equals 0, that's equal to 0, 30 minus 30 plus x times 500 minus 10x. Okay, will give me the zeros, which means that's factored form, so I can just say 30 plus x equals 0, or x equals minus 30. And then for this one, or 500 minus 10x is equal to 0. In other words, minus 10x equals minus 500. Now if I divide both sides by minus 10, minus 500 divided by minus 10, these become positive. I get rid of the 0, and x is equal to 50. So right here we see that that's equal to minus 30, and that's equal to 50. Now if you weren't able to know this right away, I drew this beforehand because I could see it. But you don't necessarily, you're not necessarily going to have seen that the parabola looks that way beforehand, okay? That'll be on the negative. That's something you would draw now. You would kind of see that right here, oops. Right here, it's probably minus 30. And over here, it's probably 50. And we're gonna look at, that's where my zeros are. And the midpoint between that x value is going to be where my maximum occurs. How many price increases will give me a maximal revenue? So let's find the midpoint. Minus 30 plus 50 over 2. So 4 axis of symmetry. I do my zeros, and I add them, and I divide by 2. And that's equal to 20 over 2, which is equal to 10. So my axis of symmetry is x equals 10. So what does that mean? That answers my question. My question asks me, what ticket price will maximize revenue? So I have 10 price increases. 10 price increases of $1 will maximize revenue. But 10 price increases from what? 10 price increases from 30. So 30 plus 10 is equal to 40. So a price of $40 should be charged to maximize revenue. Okay, question C, finally. It asks us, what is the maximum revenue? Well, I have this equation right here. I'm just going to copy this equation right here. That gives me revenue in terms of, it gives me revenue in terms of price increases. So at x equals 10, revenue Rx, or sorry, I should say We shouldn't even say R at X. This is how we should write it. R at 10 is the maximum revenue. So R at 10 equals 30 plus 10, 500 minus 10 times 10, which is equal to 40 times, this is 30, but plus 10, oops, what did I say that, 40? It should be, yeah, it is 40. Multiplied by 500 minus 10, 400. 500 minus 100. Let's just write it out, actually. 500 minus 100. What's that equal to? 40 times 400, which is equal to $16,000. So the maximum revenue is 16,000 at a price of 40. And that is question